Welcome to today's Explainer. Look, let's just jump right into this, because today we're not just looking at the universe as some giant sterile laboratory of discovery. We're treating it as the setting for an intense, edge-of-your-seat cosmic thriller. Space is genuinely as mysterious as it is incredibly dangerous. And while human scientists are constantly coming up with brilliant new tech, the universe harbors forces so unimaginably colossal that if they were to actually set their sights on us today, human science and our defiance wouldn't mean a thing.
It's a super comforting thought, isn't it? We look at our modern advancements and think, can human technology truly protect us from everything out there? We managed to tame our environment here on Earth, for the most part. But out in the grand theater of the cosmos, we are completely and utterly outmatched. The phenomena we're about to dive into aren't just scientific anomalies. They're essentially the unstoppable villains of our story. They're silent, they are wildly powerful, and they could not care less about our planetary defenses.
Section 1. Death at light speed. Let's start with the most terrifying assassin out there, the one you literally never see coming. We're talking about gamma-ray bursts, or GRBs. Now, this isn't just your run-of-the-mill cosmic explosion. It is an immense, hyper-focused blast of energy released during the most violent deaths imaginable in space. This happens when an impossibly massive star collapses in on itself to form a black hole, or when two hyperdense neutron stars violently smash into each other. The sheer amount of energy released in just a few seconds is more than our entire sun will produce over its 10 billion-year lifespan.
To put that into perspective, picture a danger zone of about 10,000 light-years. If a GRB were to go off within that radius, and its beam just happened to be pointed directly at Earth, like a cosmic sniper rifle, the consequences would be absolutely apocalyptic. That beam would hit our atmosphere and completely vaporize our protective ozone layer in seconds. And without that ozone layer, all life on Earth would be instantly exposed to and burned by the sun's lethal, unfiltered radiation. But here is the truly chilling part. We wouldn't even have a moment to panic. Since these deadly rays travel at exactly the speed of light, the light that would allow our telescopes to even see the burst happening would arrive at the exact same moment as the deadly radiation itself. By the time we know it's there, it's already hit us.
Section 2. Wandering monsters of space. So, moving on from light beams to something with a bit more gravity.
Forget the myth that black holes just sit obediently in the center of galaxies like giant cosmic drains. The universe is actually teeming with millions of invisible, wandering monsters moving aimlessly through the dark. Imagine a rogue black hole silently drifting just a little too close to our solar system. It wouldn't even need to swallow us to ruin everything. Its massive gravitational pull would violently warp planetary orbits. It could literally drag Earth out of our comfortable habitable zone, either throwing us directly into the fiery inferno of the sun or slingshotting us out into the endless freezing abyss of deep space.
And the ultimate stealth factor here. Black holes swallow everything, right? Even light. They don't emit any kind of warning beacon, making them almost impossible to spot against the dark backdrop of space. By the time astronomers notice the unnatural gravitational pull messing with nearby stars or the outer planets, that unstoppable gravity would already have us in its grip. There's just no earthly technology that can fight gravity on a stellar scale.
Section 3. Destructive end of stars. Now, the threats don't just wander in the dark. Sometimes they're shining right above us in the night sky. When a massive star reaches the end of its life and detonates in a supernova, it's an explosion so breathtakingly violent it can briefly outshine an entire galaxy. The threshold for survival here is roughly 30 light-years. If a star within that 30 light-year bubble were to go supernova, a brutal shockwave of deadly cosmic rays would hurtle towards us. These high-energy particles would pierce right through our atmosphere, tear apart the chemical bonds of our air, and completely devastate the global ecosystem, leaving Earth a barren wasteland.
And against an event of that magnitude, what exactly are we going to do? The hard truth is, humans cannot stop a star from exploding. And we certainly can't build some sci-fi Earth-sized magnetic shield to block a cosmic radiation storm. Against a supernova, we are 100% exposed.
Section 4. Surprise massive asteroids and comets. Okay, let's bring the danger a little closer to home.
We all know the story of the dinosaur-killing asteroid, but in this thriller, a 10 to 15-kilometer rock is just the prologue. There are far larger, way more terrifying rocks lurking out there in the deep freeze of the solar system. Now yes, humanity recently had a massive win with the DART mission, successfully deflecting a small asteroid. But compare that to a giant, surprise comet from the distant Oort cloud, a behemoth 50 to 100 kilometers across, coming in hot and fast. If we only detect a monster like that a few months before impact, our current technology is completely useless against that much mass and momentum.
I know. You're probably thinking, well, what about our ultimate weapon? Just nuke it, like in a blockbuster movie. Actually, scratch that. Blowing up a 100-kilometer-wide asteroid right before it hits us wouldn't vaporize it. It would just shatter it into millions of massive, highly radioactive boulders. Instead of one giant impact, we'd be subjecting the entire globe to an inescapable, catastrophic rain of fire. We'd basically be turning a single cosmic bullet into an unstoppable shotgun blast. No thanks.
Section 5. Terrifying Truth of Quantum Physics. We are leaving astrophysics behind and entering a deeply unsettling realm right now. Welcome to the ultimate existential threat, false vacuum decay. It's theoretical, sure, but it is deeply grounded in modern physics. The idea is that the very fabric of space we live in might not actually be in its most stable, lowest energy state. It might be a false vacuum. If even a single point anywhere in the universe somehow drops into a lower energy, true vacuum state, it would create a bubble of new reality. This bubble would expand outward in all directions, completely erasing atoms, planets, stars, and fundamentally rewriting the laws of physics themselves as it goes.
And because this bubble of true vacuum would expand at exactly the speed of light, we are back to that ultimate terror. Absolutely no warning. 1 second we're here, just living our lives, and the very next second, absolutely everything is gone. The ultimate cosmic eraser. It would be instant, painless, and completely unstoppable.
Section 6. Are we safe? Okay, everybody take a deep breath. We've just walked through the absolute darkest, most terrifying scenarios the universe has to offer. But in any great thriller, right when the tension is completely unbearable, you get a plot twist. And today's twist is a massive wave of relief. When you actually compare these catastrophic events to their true likelihood, a totally different picture emerges. GRBs, rogue black holes, supernovas, vacuum decay, yes, they are terrifying. But their chances of actually happening? Astronomically low. We're talking once in millions or even billions of years. It turns out, Earth is nestled in a remarkably quiet, incredibly safe, and beautifully stable neighborhood of the Milky Way. The universe isn't actively trying to destroy us today. We are incredibly safe for now. We exist in this golden window of cosmic calm. But understanding these unstoppable forces shouldn't leave us paralyzed with fear. It should really just fill us with a profound sense of awe. If the universe possesses forces capable of erasing reality at the speed of light, what other incredible, entirely unimaginable mysteries are out there just waiting to be discovered? What else can the extreme edges of physics and the dark void of space teach us about our own fragile, precious existence? Now that is a mystery worth exploring. Thanks for joining me on this explainer, and keep your eyes on the